As we saw in the first example, when velocity is positive, we can think of the distance traveled as the area under the curve of the velocity function. When the velocity is not constant, we estimate the area under the curve using rectangles. For example, say we are given the following velocity curve, and we want to estimate the distance traveled between time A hours and B hours. We might calculate the area under the curve using only two rectangles. We take the interval from A to B, separate into two equal subintervals, and use the value of the function on the left as the height of our rectangles. We could then use the area of those rectangles to represent our area under the curve. But you'll notice that this calculation does not give us a very accurate area under the curve. So say we look at it again. We're going to take our interval from A to B, but this time instead of dividing it into two equal subintervals, we're going to divide it into four equal subintervals, again using the value of the function on the left as the height of each of our rectangles. We then use the area of these rectangles to represent the area under the curve. Our estimate is a little better, but still not great. We're going to do it one more time, this time using 8 rectangles. So we still have our interval from A to B. Instead of using 2 equal subintervals or 4 equal subintervals, this time we're going to use 8 equal subintervals. We're still going to use the value of the function at the left end point as the height of each of our rectangles. And use the area of those rectangles to estimate the area under the curve. You'll notice this time that we have almost entirely shaded the area under the curve of the velocity function. What we realize is that the more rectangles we use, the better the estimation. So, suppose we have a function f of x that's continuous on the interval from a to b. The definite integral of f of x from a to b, written as the integral from a to b of f of x dx, is the limit of the left-hand or right-hand sums within subdivisions of ab as n gets arbitrarily large. So, if we take our number of rectangles and let that go to infinity, the end result will be the value of the definite integral of f of x.